This is now the continuation of the population ecology PowerPoint, and now we're going to start the section of the PowerPoint dealing primarily with aquatic systems. Our aquatic, in terms of ecology, our aquatic systems are basically divided between fresh and salt water. They are the two largest bodies of water in terms of water supply on the planet. Is either going to be fresh or salt. Now there are some other types of, we have brackish water and so forth, and there are other waters that are just so heavily polluted that you don't classify them as fresh or salt, but they were once either fresh water or salt water. Fresh water is basically water that has very, very, very low amounts of salt. In fact, less than 1%. Now the peculiar thing about it is that our ocean is basically about 30% salt. So there's a 30% salinity in salt water. Yet fresh water is constituted as having less than 1% concentration of pure salt. So one would say, okay, well then what happens when water is 15%, 20%, 10%, anything above 1 but below 30 to 33? It's still constituted as salt water, except it would be salt water, like if it was 20%, it would be salt water but with an extremely low salinity. Plants and animals depend primarily on fresh water. They have adapted to certain areas on the planet that have low salt, and some other animals have adapted to areas of high concentration of salt. But regardless of which one of the two, they are, plants and animals both, are highly dependent on our fresh and our salt water supply on the planet. Fresh water consists primarily of ponds and lakes, streams and rivers, and our wetlands. We are very fortunate here in South Florida to have the Everglades to observe and to learn from. It is a wetland unlike any other on the entire planet. Even the bayous, even the swamp areas in Louisiana are completely unlike, well not completely, but very different than the wetlands in Florida here in the Everglades. And again, people from Louisiana can pretty much say the same thing about us as well. That their swampland is very, very, very different than ours, and there's none like it on the planet, which is great. Both of them have a huge commonality. They are both aquifers for their respective regions. Now what that basically means is that in terms of purifying water here in South Florida, the Everglades does that, and it actually does that very well. And so because of that, the Everglades as a whole is a protected area. And we as citizens always have to make sure that we do our absolute very best in protecting our natural wetlands, our Everglades. Because again, let's learn from the mistakes that we made with the ozone layer and not do the same thing with our Florida aquifer. Because once we ruin it to an irretrievable point, we can regret till we're blue in the face. We're not going to be able to get it back. Our ponds and lakes range in size. We can have ponds and lakes that are very small. Lake Okeechobee is actually a very large lake. In fact, you can stand on one side of Lake Okeechobee and not see the landform on the other. clearly. In fact, when you stand in Lake Okeechobee, it would basically look no different than if you were standing in Miami Beach. To you, you're just going to see vast miles and miles of water. You have not equally as strong currents as you do on the Atlantic side, for example, but nonetheless, you can get a really strong current in Lake Okeechobee. It's a very large body of water. Lakes and ponds have their issues, though. They're seasonal sometimes. Sometimes they do dry up, especially in Africa, for example, how we were seeing on the video the other day. When the dry season comes around, these lakes and ponds entirely can dry up, and they'll stay dry all the way up until rainy season comes around. They're limited in species. If a lake or a pond is closed off from any other body of water, then the only species that have ever existed in that lake and pond will be the only one found there. So they're limited in the diversity of species found. And yeah, you could find a particular species of animal, fish, plant from one to the other, but guess what? If these ecosystems are completely isolated from each other, one would never cross to the other. Streams and rivers. We depend highly on our streams and rivers. Our streams and rivers provide us with our drinking water. We use streams and rivers to irrigate our crops. And they are a huge part of our water cycle. Big difference between streams, rivers versus lakes and ponds. Here, water is what? Water is moving. Now that's important in terms of levels of humidity, diversification of bacteria, formation of algae. If you look at this, scenic wise, it's a beautiful picture, but we have a diverse ecosystem here in terms of the algae that forms here, and all sorts of different types of mold and bacteria that can exist here. Moving water also limits other types of bacteria. It lowers humidity in certain cases, but at the same time, the warmth issue in the atmosphere surrounding trees, the levels of the area can sometimes trap heat, and that also is a good thing for certain bacteria to grow, and algae and fungi to grow in these environments as well. They are seasonal as well. During the winter, this will basically, heighten. The picture here was taken in the winter, and during the summer, a lot of this bacteria will die off because of the heat, and it will come back and cycle around as well. And then again, our wetlands are the areas of standing water, and marshes, swamps, bogs, the Everglades, all consists of this. The picture in the background is not the Everglades, it's actually the bayou in Louisiana. We don't have the same depth of water here. But the big thing with wetlands is they are a huge supporter for plant life. Plants thrive very well in wetlands. And when plants do very well in wetlands, then species of insect, species of fish, and species of small mammal will also do very well in these environments, in these ecosystems as well. They may not so much be such a huge contributor to the water cycle. They are, because water will evaporate from any body of water, but they don't contribute as much as rivers and streams do, for example. Unless they're in a large open area of water, then they will equally take part in that water cycle. Our marine environments cover about 3/4 of the planet. You've known that. Algae supply take up much of the world's oxygen, and what they do is they take in huge amounts of what we call atmospheric carbon dioxide. I think I spoke to you guys once long ago about dead zones, when algae starts to build up excessively in an area of an ocean. It creates a dead zone. Algae starts to overconsume the oxygen in the water. And when the oxygen in the water is depleted, then no life can live there. Fish must breathe from the oxygen in the water. When water is deoxygenated in trapped areas, fish will leave. And all aquatic life, for that matter, will end up leaving. So we call it a dead zone. In the last PowerPoint that I talked to you guys about that, it showed the dead zone as being right around the Gulf of Mexico and really close to land. We have a lot of dead zones there. Our marine that cover the 3/4 of the planet are our oceans, coral reef, and our estuaries. A lot of water evaporates from our oceans and becomes part of the water cycle. Our marine ecosystems, like I said, our oceans, our coral reefs, and our estuaries make up our various marine ecosystems. So oceans dominate basically the Earth's surface. They are separate zones. Intertidal, obviously we know that our tides operate heavily on our oceans. We have different factors of oceans. We can have either coastal ocean or open ocean. Obviously self-explanatory. Coastal ocean means the ocean where it meets land, so our beaches. Whereas to open ocean is basically that, out there in the middle of the ocean, not near any body of land. One of the big things that I want to point out in terms of our oceans, diversification of life. We have so much diversification in terms of finding different species of life in our oceans that we could find higher numbers in terms of diversification, higher numbers of different species in our ocean than we do on land. So that's quite astounding. Our coral reefs are constructed by layers and layers, repeated layers of small organisms, coral, marine organisms, sand, different types of sediment, excuse me, and they all make up our coral reef. Coral reef is a living organism. Okay, we do have what we call live rock that make up part of coral reef, but they are living organisms. They are known as the largest food supply and the balancer of our oceans. Coral reefs balance in the ways that they provide homes for many fish. They provide a constant food supply for small marine animals like very tiny fish and small crabs, things like that. The biggest threat to coral reefs are the accumulation of carbon dioxide and global warming. Believe it or not, global warming does threaten our coral reefs because it is warming up our water. And our waters for the creation of coral reef need to be somewhat cold. This is the reason why we don't really have a lot of coral reef off our coasts here in Florida. We do have some that are sunk. We sometimes sink particular ships on purpose in a particular area because we know that in a few decades coral reef will grow all over it. And if you've seen pictures of the Titanic, for example, you see that there are many areas covered with the development of coral reef all over the ship. And that ship has been down there for quite some time now. It is a lengthy process, but it is something that we do to help our marine environments. Our estuaries, I mentioned brackish water a while back ago. Our estuaries are our transition zones between salt and fresh water. It's all water in estuaries is called brackish water. They actually create a pretty cool environment. They have a good diversification of species, and you find certain plant life, mangroves and things like that, and certain animals, freshwater crocodile, saltwater crocodile, and these are animals that we actually have here in South Florida as well. That, remember, the crocodile is not native to Florida, but it has evolved over the course of time in estuaries. Alright, so real quick, can you tell me any natural disaster that have affected human populations? Obviously, we're very, very, very familiar with those living here in South Florida. But yes, hurricanes do affect our human populations. Flooding affects human populations. I don't want to go too into it, but I can't begin to talk about the devastation that Katrina formed in Louisiana, and many people lost their lives. Death rate goes up when we get these situations of catastrophic situations and natural disasters, earthquakes and things like that, do take lives, and all at one shot too. So they do affect our human populations. But it's not only in the form of death. They also affect human populations what other way? Correct, when people move away. When people move away due to, oh, I don't like where I live, I don't like hurricanes, it destroyed my house, it did this, it did that, and stuff like that. And there are people, quite frankly, that just prefer living in parts of the world where we don't have hurricanes but do have earthquakes. Or, certain people that live in areas of mudslides, things like that. So, or maybe the only thing that they deal with is just snow. In Canada there's no hurricanes, affecting majorly there. They don't have tornadoes. What they have is snow. And sometimes people are okay with snowstorms and so forth as being their worst case scenario. But natural disasters do affect human populations. They affect them globally. They affect them obviously in Florida here. Like I said, hurricanes affect us greatly. Real quick question, how can the addition of excess nutrients to a lake threaten its fish population? I talked about a dead zone earlier, and a dead zone would be a an accumulation of carbon dioxide, a lack of oxygen in the water. Now that excess carbon dioxide would threaten the fish population because it kills everything off in that area, creating a dead zone. Changes inside of our communities that are related to water could be seasonal, a climate change, and succession. The picture here shows succession. You have annual plants and perennial plants that start to are basically one of the first plants that come back when an area is wiped out. Seasonal variations cause certain plants to leave at certain times of the year and come back in other times of the year. Now this is important to coastal areas because what happens to coastal areas when they lose their plant life? Weathering and erosion increases, and that's important. All those nice hotels that we stay at on Miami Beach, we want those hotels to last for a very long time. So we have to protect our sea bank. We have to protect our coastal area. We have to protect the beaches. And plant life keep these areas from weathering and eroding. Now here in Florida, yes, we don't really have too many climate changes. But on the coast of North Carolina, Virginia, and the whole New York area, they do. So climate changes are important for those plant lives to try to adapt and go through it, because those coasts also need to be protected as well. And sometimes the coast will get completely wiped out, and so succession has to occur. The plants that, we go through a primary succession and then a secondary succession, but it is in an overall where life finds a way to come back. Biodiversity is important. Again, you cannot have evolution become stagnant. And the one thing that's going to make evolution become stagnant is when you lose your biodiversity. If man had not diversified from millions of years ago, then all of you would still have that large protruded jaw and those ugly teeth, and every orthodontist in America would be completely rich because everyone would need braces. So we need biodiversification. Catastrophic events make us lose our biodiversity. It took the Florida Keys some time to recover from a hurricane that we had back in 1992. How many of you have heard of Hurricane Andrew? Andrew did a lot of damage to South Florida, and there's a point in South Florida called, if memory serves me right, Key Point Marina, and that marina was filled with mangrove, and all those mangrove came down during Andrew, completely devastated, completely destroyed. So catastrophic events make us lose biodiversity in terms of plants and animals that have to relocate. Climate changes, we just spoke about that now in terms of plants that can't survive the winter and basically leave the area during the winter. And so they come back in the spring when the weather warms up a little bit. Human activities. We all know every time we clear out an area, build a shopping center, build a street, we lose a diversification of plants and sometimes certain animals that used to live there, where we, tore that area off. Pollution is another human activity that can lower biodiversity. And the introduction of invasive and non-native species. Now, I'm not going to go into it now, but I'd like you to Google at some point, if you really want to get into that, the problems with our pythons in the Everglades. So if you just Google python in the Everglades, you'll see a whole bunch of different articles that talks about the huge problems and the loss of biodiversification by simply introducing a snake like the python from South America that doesn't truly belong here, and the problems that it is causing. Now, some of the things that we need to be familiar with. Urbanization. We tear down an area and we're building there. We are expanding our residential areas. Well, that right there creates a disturbance in our ecosystems. Now, this area here is mountainous terrain. So what does that have to do with aquatic systems? Well, if you look closely, in this area right here, you see what could be a river or a stream. Well, if that river or stream would flow down the mountain this way, maybe it used to go here, but now we have to redirect it to come this way because we're building here and we're building here. Sometimes that works out just fine. Other times it doesn't. Other times we disturb nature to the point where it can't recover. So this could sometimes be a problem. We're trying to go paperless. Everywhere that we see, all these major companies are always trying to go paperless. Why? To try to avoid this, the loss of all these trees that we lose. So yes, we do need to follow the 3 R's, and we do need to try to conserve wherever possible. Deforestation is, sometimes we do it for the paper product, other times we do it for furniture, housing, things like that. And other times we do deforestation because we're trying to what? Build on the land. So this is also sometimes a little bit of a problem as well. And again, air pollution. Just the same way that people can develop lung cancer through secondhand smoke. We talked about that on the Do Now the other day. Animals can develop their equivalent of lung cancer, emphysema, and things like that from air pollution. So that's also a problem as well. We have to try to make sure that we conserve as much as possible. All right, let's do a couple of questions real quick. Food, water, shelter, and space in which to live all describe in organisms what? Going with C, habitat. That's correct. All right, good. Which is a natural cause of ecosystem change? There we go. We're talking natural. Again, farming we do, building fences we do, pollution we do, but hurricanes are natural causes that can create an ecosystem to change. Which of the following best describes biodiversity? All right, yes, a variety of all life on Earth. Okay, that concludes the PowerPoint on population ecology. Obviously, if you're watching this, you're fully aware that this was split up into two. Our next PowerPoint deals with things that we do and how those things can affect our ecosystems throughout the planet. The human interaction. That's the next PowerPoint after this.